This is the Unit 6 review. So we start with the unit circle. So right now, why don't we take a moment to try and fill in as much as we can of the unit circle. So if you're watching at home, try that now. Okay, here we go. So hopefully you've had a try. How was it, guys? Did we do okay?
Yeah.
Okay, we filled it in?
Coming back, yep.
Okay, so I think remembering that the larger segments are worth 30 and the smaller segments are worth 15 is key, and the larger segments are worth pi over 6, the smaller segments are pi over 12. Or you can think about it like a large segment and a half segment together is 45 degrees or pi over 4. That helps you fill everything in. So you have 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then radians we have 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 8 pi over 6, 4 pi over 3, 3 pi over 2, 7, 8, 9 pi over 6,
5 pi over
9 pi over 6,
5
10
pi over 3.
10 pi over 6, 5 pi over 3, 6, 7 pi over 4, and then 11 pi over 6. Okay? So there's the radians, and those are the degrees. And then our coordinates, our corner points are easy, right? We have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then we have, I think about it like the small segments are 1/2, the medium segments are root 2 over 2, and then the big segments are root 3 over 2. And then it mirrors it on the x. So big root 3 over 2, medium root 2 over 2, and then small 1/2. So we're going to have root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2. And then from there, we can just mirror it across, right? That means if this is root 3 over 2, this also has to be root 3 over 2, and then root 2 over 2, and then 1/2. This is 1/2, negative 1/2, negative root 2 over 2, negative root 3 over 2, and then down bottom, all negative. So negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, and negative 1/2, negative root 3 over 2. Move it to the right, bless you. 1/2, negative root 3 over 2, root 2 over 2, negative root 2 over 2, and then root 3 over 2 and negative 1/2. Okay? That's the unit circle. Pretty straightforward, right? We just need to know it. Okay? Put a point in a unit circle problem. If a point in the unit circle has a y value of 12/3 and x is less than 0, find all 6 trig functions. So if x is less than 0, I'm on this side. If my y value is 12 over 13, that means it's pretty high up. It's over here somewhere in the unit circle. So my y value here would be 12 over 13. Yeah, sorry. This is 12 over 13. The radius or the hypotenuse of the unit circle is always what? It's always 1. Okay, so I know this side. I know my hypotenuse. I have to find the short side, so I need what theorem? Pythagorean theorem. So we're going to say 1 squared equals 144 over 169 plus some x squared. 1 minus 144 over 169 what is that? What's left over here? 25? 25 over 169 equals x squared, so that means x equals 5 over 13. Yeah? Do we follow that okay? So this is 5 over 13, but it's going to be negative because we're in, sorry you can't see that, it's not good, because we're in the quadrant 2. Are we following?
Yeah.
And now we just plug in to get the ratios. So sine, opposite over hypotenuse, and so on. Good?
Yeah.
Should I do it? Are we good?
No.
Okay, I think we're good. All right. All right, graphing trig functions, the basic trig functions, here we go. How are we on this?
You start at like 1.
Okay, so for graphing sine, you can use your unit circle to help you. What is sine at 0?
0.
Then we go up to,
1.
and then we go back to,
0.
and then we go to, and then we're back to. There we go. So let's do that. So 0. I'm going to call this 1 and this -1 for all of these, just so we have like some scale. So up to 1, down to 0, down to -1, back to 0. We have a period of 2 pi, right? And then it mirrors this going backwards. Oop. Okay. For cosine, it's similar, but the difference is we start at 1 and then we descend down to pi over 2, down to -1, back up to 0, and back up to 1. Still a period of 2 pi. Okay. For 10, okay, so how do you remember 10? So remembering that 10 is what ratio? 10 is sine over cosine, right? So you're going to have vertical asymptotes whenever cosine is what? Whenever cosine 0. So when is cosine 0? When does that happen? Pi over 2. So go pi over 2, and every pi, right? So 3 pi over 2 as well, and at negative pi over 2, and at negative 3 pi over 2, right? We're going to have these vertical asymptotes. And then when sine is 0, the function's going to be 0, right? So when is sine 0? Sine 0 at 0, at pi, at 2 pi, at negative pi, at negative 2 pi, right? And so all you have to remember is in between, we go from low to high. So we go from negative infinity up to infinity, we go from negative infinity up to infinity, we go from negative infinity to infinity, and so on. And you can always like use your unit circle to reference that. Cotangent is really similar, right? But it's different how. What's cotangent? It's not sine over cosine, it's cosine over sine. There we go. So it's cosine over sine. So we're going to have those vertical asymptotes not at, everything's going to do what? Things are going to
Shift.
Yeah, they're gonna switch, right? They're like the asymptotes of 10 are the zeros of cotangent, and the zeros of tangent are the asymptotes of cotangent, right? Because that's where sine is sine 0. So we're gonna have vertical asymptote at 0. We're gonna have a vertical asymptote at pi, and at 2 pi, and at negative pi, and at negative 2 pi. And where are we gonna have zeros?
Pi over 2 and
Yeah.
pi over 2.
Yeah.
And negative pi over 2.
And then the other difference is rather than going from low to high, rather than increasing, cotangent decreases.
Wait, why? Is it like as it goes like?
I'll show you in just a second. Okay, so again, like you can always think about it like thinking with a unit circle, you're dividing the x values by the y values. So we're dividing big X values by increasingly smaller y values when we're doing cotangent, right? So we're doing, we start off with that vertical asymptote with very small y values, and so it's infinity, and then it approaches eventually 0,
So that's
and
why it's
then
getting less.
yeah, and then we're dividing by big y values, but now it's negative cosine, small negative cosine divided by big y value, and so on. That's why it's decreasing. You can think about it like it's these x values divided by the y values. All right, two left, cosecant and secant. There's the key points to look for with cosecant and secant. Remember this? So what is cosecant? It's 1 over sine x, and then secant is 1 over cosine x. So nice points are going to be very similar to above. Are what? We want to look for where we have asymptotes, which for sine is going to be 0 and pi and 2 pi and negative pi and negative 2 pi, right? And then other nice points is when sine equals 1. So when sine, or negative 1, right? So sine equals 1 at pi over 2. Sine equals negative 1 at 3 pi over 2, right? Negative 1 at negative pi over 2, and then 1 at negative 3 pi over 2. And then, do you remember what it does, the behavior of the function? It goes, yeah, it doesn't cross the x-axis. It just approaches those vertical asymptotes to negative infinity or infinity. For secant, it's very, very similar, right? The same idea. Where do we have vertical asymptotes? We have them at pi over 2 and 3 pi over 2 and negative pi over 2 and negative 3 pi over 2. And where do we have 1? We have 1 at 0, and we have negative 1 at pi, and we have 1 back at 1 at 2 pi, and we have negative 1 at negative pi, and then back to 1 at negative 2 pi, and it's the same behavior. We approach those vertical asymptotes. We don't cross the x-axis. That's it. Okay. I think it's the last segment. Okay, last part of chapter 6. So some transformations. So as I'm with the test, I'm not trying to throw you any curveballs. So when we talk about the transformations, like be familiar with sine and cosine with transformations, and be familiar with the general like shape of the above. Right? Does that make sense? When we talk about transformations, I'm talking about sine and cosine. Okay. For transformations. Mm-hmm. So what is going on here when we have, what's this 2 going to do to this function? It's going to change the vertical. Remember the amplitude?
Yeah.
Right, so that's the amplitude is going to equal 2, right? That's a vertical stretch of 2, and then that 2 on the inside is going to change the what? It's going to change the period. So the period equals 2 pi over the absolute value of b. So in this case, our period is not 2 pi anymore. Our period is just going to be pi. Okay? So let's think about what does sine look like? Well, sine still starts at 0, but I should do a full rotation in 1 pi. So instead of being at pi over 2, I'm going to be at pi over 4, and then I'm going to come down at pi over 2, down at 3 pi over 2, and back at pi. That would be one complete rotation. So this is a period of pi, and then we're going 2 high and 2 low. Does that make sense? Did I go too fast there? So amplitude is 2. That means we're going not up 1, down 1. We're going up 2, down 2. And then the period is not 2 pi anymore. It's 2 pi over 2. So the period is pi, meaning that your frequency has increased, right? We are horizontally shrinking by a factor of 2. So what was at pi over 2 is now at pi over 4. What was at pi is now at pi over 2, and so on. Okay, and then it would continue this pattern. Okay. For negative 3 cosine x plus 1, what is going to happen here? Amplitude is going to be still 3, yeah. The period is not going to change. We're going to vertically shift what?
Up 1.
Yeah.
And then reflect it.
And then reflect over
X.
x-axis. Good. Thanks, buddy.
Thank you.
All right. So cosine normally starts at what value? Cosine 0 is
1.
1, but now we're going to start at, we're going to multiply that by negative 3, so we're going to be down at negative 3, 1, 2, 3, but then we're going to go up 1. Okay. Let's do the key points. At pi over 2, cosine pi over 2 is normally what? Cosine pi over 2 is normally 0,
0.
but then we're going to add 1, so it'll be up at 1. We're at pi, cosine of pi is normally negative 1, but we're going to multiply by negative 3, we're going to get 3, and we're going to add 1, so we're going to be up at 4. And then 3 pi over 2, we're back down at the 1, and then at 2 pi, we're back where we started. So then I can connect the dots. And then we'll mirror that. All right, that's chapter 6.